Hello and welcome to our lesson on composition of functions with inverse trig. So our icebreaker was tell me your student going to school during a pandemic without telling me your student going to school during a pandemic. So my example was one of my kids who are obviously they're going to school doing distance learning. Last night, one of them had a dream that they couldn't find their Chromebook and had to drop out of school. So if you want to, on the next slide, on the collaborate slide, you can share an example of pandemic schooling that illustrates what you are dealing with. All right, so here's what we're doing in this lesson. So we have evaluating compositions of inverse functions, right? So we've looked at the graph, we've restricted the domain, and now we are going to look at evaluating composition functions. So we have our icebreaker. This is the objective agenda, warm up. We're going to practice some compositions. We'll take a brain break. If you're watching this video asynchronously, you won't be able to participate in the time to climb, but that's what we're doing in class. And then we have the intro to sum difference identities, and then we'll close. Remember that homework and formative from week 4 were both due March 3rd, and then week 5 are both due March 10th. There's no school March 8th. There's going to be an asynchronous assignment, which will be a progress check review in my MCPS classroom Sunday night. You can either do it during regular class time or next week. Interims are March 12th, and then progress checks are March 24th. Okay. So this is a warm up. So you would do this. It was sine to inverse sine of negative square root of 3 divided by 2. It looks like it didn't show up very well on the quiz slide, so we might need to add an image. All right, so we're going to go ahead and work on some composition function problems. So a composition problem is really basically a problem nested inside a problem. So we'll do this first example. This right here is a problem nested inside a problem. If you see cosine of inverse sine of negative root 2 over 2, right? It's a problem within a problem. So what we're going to do first is just evaluate the inside. So the inside is inverse sine of negative root 2 over 2. So let's just do that first, and then we'll deal with the outside. So inverse sine of negative root 2 over 2. So remember that for inverse sine, our range is restricted to negative pi over 2 to pi over 2. So where is our sine? Where on the right side of the unit circle? Because that's where our sine range is, right? Domain -1 to 1, and then range -2 pi to negative pi over 2 to pi over 2. Where is the sine negative root 2 over 2? It's right here at negative pi over 4. Okay, so basically now what we have to do, now we know what the value is here, we have to take what's the cosine of negative pi over 4, right? Cosine is not a restricted domain the way inverse trig is, right? So you just look at where you're at negative pi over 4, and then what's the x value there, what's the cosine, and that's going to be root 2 over 2, and that's it. Okay. Since this is on YouTube, you can pause it anytime you want. So just if you need to take another look at it, pause it. Okay, let's do another one. So again, we have a problem within a problem. So we have the composition is the sine of inverse tangent of 1. So it makes sense to first figure out, well, what's inverse tangent of 1? Okay, remember the range for inverse tangent, same thing. Right half of the unit circle, right? So where do we have a y over x that's equal to 1? It's going to be pi over 4, right? Because that's where you have a matching x and y. Root 2 over 2 divided by root 2 over 2 is going to be 1. So inverse tangent of 1 is pi over 4. Sine of inverse tangent of 1. So what's the sine of pi over 4? It's root 2 over 2. So make it a little clearer. So sine of pi over 4 is root 2 over 2. Okay, another one. So this one actually has the angle on the inside and then the inverse on the outside, but that's okay. We're still going to do the same thing. We're going to evaluate the inverse. So the interior expression first. So inverse cosine of sine of pi over 3 is inverse cosine of whatever this is, right? So let's figure out what that is. Pi over 3 falls right here. So the sine of pi over 3 is root 3 over 2. Root 3 over 2. Okay, and then the inverse cosine of that, inverse cosine of root 3 over 2. So now we have to look where on the circle. And again, for inverse cosine, we use the top half of the circle. Where is the cosine of an angle root 3 over 2? So let's look. Right here, we have an x of root 3 over 2 here at pi over 6. Or you could say 30 degrees if you're working in degrees. Okay. Okay, we'll do a couple of mixed examples just to fuse all these skills together. Okay, so inverse cosine of sine of pi over 3. So that's inverse cosine of whatever sine of pi over 3 is. Pi over 3 is right here. That's root 3 over 2. Right, so I've just solved sine of pi over 3. It's root 3 over 2. What's inverse cosine of root 3 over 2? Okay, so where is x root 3 over 2? Right here. Pi over 6 or 30 degrees. Okay, so again, we solve the inside problem and then we solve the outside problem. Okay, so next we've got inverse sine of cosine of 3 pi over 4. So we have to deal with what's cosine of 3 pi over 4. It's over here. So cosine of 3 pi over 4 is negative root 2 over 2. So this is inverse sine of negative root 2 over 2. Okay, what is the inverse sine of negative root 2 over 2? Remember, inverse sine lives on the right half of the unit circle. Be really careful with that. We're only taking these values on the right half of the unit circle. Okay, negative pi over 2 to pi over 2. Okay, so where do we have a sine of negative root 2 over 2? Right here, negative pi over 4. And don't say 7 pi over 4 because remember, we're really restricted in that range. Okay, so negative pi over 4, or you could say negative 45 degrees if you are working in angles. Okay. Okay, so the last one here is cotangent of inverse tangent of 0. Okay, so tangent is always interesting. Cotangent and tangent are always interesting. So inverse tangent, just like inverse sine, lives here. Okay, so inverse tangent of 0, where do you have y over x of 0? It's going to be right here, right? It's going to be at 0 degrees or 0 radians. So we're really now solving cotangent of 0. Right, so cotangent is 1 over tangent or x over y. 1 over 0, oops, undefined. Cannot divide by 0. Okay. All right, so let's go ahead and have you try some. There are 2 questions here for you to try. Tangent of inverse cosine of negative root 3 over 2, and then inverse sine of cosine of pi. So go ahead and give those a try. The reminder, your unit circle is right here. Your domain and range for inverse sine and inverse tangent and inverse sine are here. Go ahead and give it a try. And now we're back reviewing it. So inverse cosine of negative root 3 over 2. So we're looking again, the cosine domain is up here, right? So where do we have an x value of negative root 3 over 2? Right here, right? At 5 pi over 6. So this is tangent of 5 pi over 6. So when we take the tangent of 5 pi over 6, see my mistake here, I was thinking something I was doing, I made a mistake, so I need to fix it. So tangent of 5 pi over 6 is 1 over negative root 3, or negative root 3 over 3. All right. So that's that on that. And then for inverse sine of cosine of pi, So cosine of pi is all the way at the top of cosine's range. So it's right here at -1, 0, right? So cosine of pi would be -1. So now you're looking at inverse sine of -1. All right, so now we're looking at, okay, so now we're looking at our sine part of our unit circle, right? So the right half. So where falling within that inverse domain is the sine -1, right? That's going to be -pi/2. I know we're going to want to say 3 pi/2, but remember we're strictly calling it this exact range. It's important that we say we're falling at -pi/2, and that's that. All right. So now you've tried it. You'll take a brain break. You'll stretch. You'll do what you need to do. You'll read about the Calitron girls for Women's History Month. And we'll do a time to climb, which is going to be really fun. And I'm sorry you missed it. Super fun. And then the last thing we'll do is Pythagorean Identities teaser for the next lesson. So we have asynchronous time next week. March 9th and 10th will be an asynchronous lesson. So March 8th, there's no school. March 9th and 10th, you'll have an asynchronous lesson. And then we'll see each other again March 11th and 12th, that Thursday and Friday. So March 11th and 12th, we're really going to teach Pythagorean identities pretty exclusively on that day. That's kind of what we're going to mostly be focused on that day. And but I want to tease it first a little bit, give you a little appetizer for the lesson. Okay, so we've got a right triangle, right? We've got A, B, and C. And let's call this angle theta. Right, so we'll have this will be the side opposite of theta. This will be the side adjacent to theta, and this will be the hypotenuse, right? So you know that sine of theta at this point, you know it's the opposite over hypotenuse. You know cosine of theta is adjacent over hypotenuse, and you know that tan of theta is opposite over adjacent, okay? So let me suggest that we think about this. So if we have the Pythagorean theorem, right, we know that O squared plus A squared equals H squared, right? Sometimes we use A, B, and C, sometimes we use X, Y, and R. It doesn't matter. The square of the short, sum of the square of the short sides equals the square of the hypotenuse, okay? And then what if we decided that we're going to divide everything in the equation by the hypotenuse squared, right? Just to see, let's see what happens. So we have opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared equals, well, anything divided by itself is 1, right? So this is actually O over H squared plus A over H squared equals 1. So this is actually telling us that the square of the sine plus the square of the cosine is equal to 1. So this is actually one of our Pythagorean identities that we're going to use as we transition to Unit 3, Topic 3, trig expressions and equations, which is going to be super fun and challenging, and I hope that you love it. All right, thank you so much for watching. That's really all I have for today. Arcsine, arccos, and arctan, also known as inverse sine, inverse cosine, and inverse tangent, help us to find measurements of angles and radian measures. And our big takeaway for today is that we can use the operation to simplify and evaluate expressions. Thank you so much for watching. Have a great day. Email me with any questions, and I'll see you next time.